Our exploration of space has brought about incredible advancements in technology and understanding. Satellites orbiting our planet have revolutionized communication, navigation, and Earth observation. However, this progress has come at a cost. We have inadvertently created a hazardous environment in space, a growing cloud of debris that threatens the very infrastructure we depend on. This debris, composed of defunct satellites, spent rocket stages, and fragments from collisions, orbits Earth at astonishing speeds. Even small pieces traveling at thousands of kilometers per hour can cause significant damage upon impact. Imagine a tiny paint chip hitting a spacecraft at those speeds. The consequences can be catastrophic. This debris poses a serious threat to operational satellites, which are crucial for communication, navigation, weather forecasting, and scientific research. A collision could cripple or destroy these invaluable assets, disrupting services we rely on daily. Moreover, the danger extends to human spaceflight. The International Space Station, for instance, has had to maneuver several times to avoid potential collisions with debris. The amount of debris orbiting our planet is staggering. Experts estimate that there are millions of pieces of debris smaller than a centimeter, over 500,000 objects between 1 and 10 centimeters, and over 26,000 larger pieces, all hurtling through space at incredible speeds. To put this into perspective, imagine a softball-sized piece of metal traveling at 28,000 kilometers per hour. That's the reality of the threat we face. This debris isn't confined to a single region. It's spread across various altitudes, creating a vast and hazardous shell around our planet. The majority of this debris is concentrated in low Earth orbit, LEO, where many essential satellites, including the International Space Station, reside. This high concentration of debris in LEO significantly increases the risk of collisions, further exacerbating the problem. The situation is only getting worse. As we launch more satellites and conduct more space activities, the amount of debris continues to grow. Each collision or fragmentation event generates thousands of new pieces, creating a vicious cycle that could eventually render space unusable. The consequences of inaction are dire, potentially jeopardizing our future in space and impacting our lives on Earth. One of the most concerning aspects of the space debris problem is the potential for a phenomenon known as the Kessler syndrome. This theoretical scenario, named after NASA scientist Donald J. Kessler, describes a cascading effect where the density of debris in Earth orbit becomes so high that collisions between debris become inevitable. Imagine a single collision creating thousands of new pieces of debris. These fragments then go on to collide with other objects, generating even more debris in a runaway chain reaction. This cascade of collisions could continue exponentially, eventually creating a dense and impenetrable belt of debris around Earth. The implications of the Kessler syndrome are alarming. A runaway cascade of collisions could render certain orbits, particularly LEO, unusable for generations. Satellites would be at constant risk, space exploration would become incredibly challenging, and even accessing space itself could become problematic. While the Kessler syndrome remains theoretical, the increasing amount of debris in orbit brings us closer to this potential reality. Section 4. Challenges in tackling the debris. Addressing the space debris problem presents significant challenges. One of the primary hurdles is the sheer difficulty of tracking and monitoring the vast number of objects in orbit. While we have sophisticated tracking systems, they are not always effective at detecting smaller pieces of debris, which can still pose a significant threat. Imagine trying to spot a marble from hundreds of kilometers away while it's moving at thousands of kilometers per hour. It's a daunting task. Another challenge is the lack of international consensus on debris mitigation and removal strategies. While some guidelines and agreements exist, they are often non-binding or lack the necessary enforcement mechanisms. This lack of a unified approach hinders the development and implementation of effective solutions. Furthermore, the technological solutions for debris removal are still under development and can be quite costly. Concepts like space-based lasers, robotic arms, and nets designed to capture debris all require significant investment and technological advancements before they can be deployed effectively. Overcoming these challenges requires a concerted effort from the global community, combining technological innovation with international cooperation. Section 5. Solutions for a cleaner space. Despite the challenges, there are several promising solutions and strategies for tackling the space debris problem. One crucial step is to prevent the creation of new debris through responsible space practices. This includes designing satellites for end-of-life disposal, such as deorbiting them into the Earth's atmosphere or moving them to graveyard orbits. Another critical area of focus is developing technologies for active debris removal, or ADR. This involves developing and deploying spacecraft specifically designed to capture and remove existing debris from orbit. Imagine a space-based garbage truck, equipped with nets, harpoons, or even robotic arms, capturing and deorbiting large pieces of debris. In addition to technological solutions, international cooperation is paramount. Sharing tracking data, developing common standards for debris mitigation, and establishing binding international agreements are all essential steps towards a cleaner and safer space environment. This requires open communication, collaboration, and a shared commitment to preserving space for future generations. Section 6. The urgency of international cooperation. The space debris issue transcends national borders. It's a global problem that requires a global solution. No single nation can solve this issue alone. It requires a collaborative effort from all spacefaring nations, working together to develop and implement effective solutions. Imagine a future where space agencies around the world pool their resources and expertise to create a global debris monitoring and removal system. International cooperation is crucial for several reasons. First, it allows for the sharing of vital information. By sharing tracking data and coordinating debris mitigation efforts, we can enhance our collective ability to avoid collisions and manage the existing debris population. Second, international cooperation fosters the development of common standards and best practices. By working together, we can establish guidelines for responsible space operations that minimize the creation of new debris. Finally, international cooperation is essential for developing and deploying debris removal technologies. These technologies are complex and expensive, and pooling resources and expertise can accelerate their development and make them more readily available. The urgency of the space debris issue cannot be overstated. It's a threat that grows with each passing day. Only through immediate and decisive action guided by international cooperation can we ensure the long-term sustainability of space activities and protect our future in the cosmos. Section 7. Our future in space, a shared responsibility. Space is a shared resource that requires responsible stewardship. Just as we protect our planet, we must preserve space for future generations. Space is an extension of our planet, demanding our care. This responsibility extends to governments, agencies, companies, and citizens. We all play a role in ensuring space sustainability. By working together, we can ensure a safe and sustainable future in space.